Before I begin lesson 4, Common Core assumes you automatically know how to take a mixed number and change it to an improper fraction. Did you learn that in 5th grade? Let me do a quick recap on it. If I give you a mixed number of 2 and 1/7, how are you supposed to change it into a mixed number? What do they? Some 5th grade teachers call it triangle trick. What do you have to do to figure this out, Nick?
7 into denominator times the whole number.
Okay. Okay. Before we even do the triangle trick, I know if my fraction is in sevenths as an improper fraction, I know I'm going to stay in sevenths. What we have to do is take the whole number and multiply it by the denominator, and then you add the numerator. So what do you wind up getting? Seal. Yes, 15/7. Try this one. 5 3/9. Okay, 5 3/9 becomes what? Brandon? Right, 5 times 9 is 45. Plus 3 is going to give us 48. Okay, one more. Do 12 1/2. Somebody want to come up to the board? Karen? (25/2) or 25/2 is good. Okay? Okay, so on that note, now that I've kind of shown you this, you can do the first 4 pages of lesson 4 on your own, because let me just tell you what lesson 4 is all about. Lesson 4 starts out with just a recap of what you did yesterday with lesson 3, and then as you'll see, when you get to page 5, they're going to introduce a new type of model called a number line to figure it out, and I kind of like the number line better. I'll explain why. And then it goes on then to then figure out a fraction divided by a fraction, but the denominators are different. What do you think you need to do in order to do a division problem with unlike denominators? Kev? Yeah, you're going to find a common denominator. So you'll see page 2 actually starts out by recapping, can you make equivalent fractions? Because you got to be able to make equivalent fractions in order to figure out what a common denominator is. So you're going to get into your groups, do the first 4 pages together. I'm going to give you about 10 minutes, and then we'll re-meet, and we'll talk about that number line model. All right, go ahead. When you create your equivalent fractions, you don't want to make them too big. You want to try to keep them as small as possible because you might need to make a number line for it. So I put up here 4 for example A and as many as 5 for example B. You may have something different, but these are the 4 smallest ones for 2/3, and these are the 5 smallest that you can make for 10/12. Like I said, there may be others. Here's the rest of the page for you to look at. Double check your answers on that. I will in 1 minute, but here's page 2, or your page 3. All right, so then when we recreate the fraction bar and do the same thing, and we start counting by eighths, you realize with this one that you will have enough to make 11/8. And it represents 1 3/8 or 11/8. And then to figure it out now, we're figuring out how many 2/8 are in 11/8. You start your leap method. There's 1, 2, 3, 4, 5, and as you can see, you don't have enough for a 6th. If there was like an imaginary box over here, that would make 6, but you're halfway between 5 and 6, so your answer winds up being 5.5. Answer is good, right? Takes us now to the number line method. Next page. Question.
Do we have to you made the counted 1, 2, 1/8?
What'd you do? You did 1/8 in every box?
Yeah.
You're fine too. Either way is fine. All right, so you can see our number line here. Here's our 0 and here's our 1. So we can see that anything past the 1 is going to be greater than 1. We're still breaking it up into eighths, so we're still going to label our number line in 1/8 segments. Let's do that now on your sheet. When you get to 1, after you go past 1, it doesn't matter to me whether you want to call it 9/8 or 1 1/8. You could keep it improper, that's fine, because you've seen it both ways now. This is the same as 1 1/8. This is the same as 1 2/8. This is the same as 1 3/8. And I am going to put 1 4/8 as 12/8 here, because it's going to help you to visualize the answer for this. Same thing. It's very similar to fraction bar. It does come in more handy when we go to example 2. I mean, I think the number line is going to work better for example 2 than a fraction bar does. All right, here's my leaps. There's 1, there's 2, there's 3, there's 4, there's 5, and as you can see, we need to get here so we don't have one full leap. We actually have a half a leap. So the answer is 5.5. Okay? Which most of you got. Now we're going to get to the whole idea behind lesson 4. Example number 2. Same starting point. We have 1 3/8. The difference now, though, is we have to break them up into servings of 3/4. And that's what we've got to figure out. This pretty much hasn't changed. You're trying to figure out in this case how many 3/4 are in 1 3/8. Or as a straight division problem, 1 3/8 divided by 3/4. Fill that in. We're going to take our 1 3/8, change it back to that improper fraction, 11/8. That hasn't changed. And in essence, we're trying to find out how many 3/4 are in 11/8. I'll let you get caught up. How is this different from what we've been doing? Leah? Yeah, the denominators are now different. That's our next page. Oh, okay. I was going to let me get to B. We can fix it by either changing 11/8 or changing 3/4. Which one do you want to change? Go ahead, Dan. 2. Yeah, we have to make a common denominator. We can't downsize 11/8 because 11 is an odd number. You can't split it in half. So we're going to upsize or upscale 3/4 and change 3/4 to 6/8. And then we're just rewriting everything. We're looking to find out how many 6/8 are in 11/8. Renumber your number line. It's a lot of writing. That's okay. going to keep it in proper. We need to get here. And now I'm going to leave it to you guys. Here's going to be the deal. I want to see if you can figure this out all by yourself. Stay at your desk. Once you have an answer, I'll do a walkthrough. If you get it right, you get a ticket. But you get only one shot, so be sure of your answer. You don't get a second chance. Because this, in my opinion here, this is the hardest part of 4. Some kids get it right away, and some kids will struggle through it. It's a leap. It's a little bit of a leap as far as a challenge. All right, so I'll leave you with that, and I'll do a walkthrough. I'm going to stop this for today. Here we go. We need to group them in groups of 6/8. Here's one full leap. There it is. So we know we have one, at least one. If I'm counting in 6/8 leaps, my second leap would get me to 12/8. As you can see, though, I don't have 2 complete. So now I know my answer has to be between 1 and 2. How much of that 2 has to be determined by looking at this piece right here. This is 1 piece. This is 2 pieces. This is 3 pieces. This is 4. This is my 5, which is where I need to go. And that's my 6th. I've gone, if I was walking this distance, 5 out of 6 lengths. So my answer is 1 and 5/6. Not 1 5/8, but 1 5/6. That's the hardest part for kids to understand, because your complete leap still puts you in between, technically on the number line, between 1 and 2. Okay? All right, enough for today. We're going to continue with it tomorrow. We're just going to practice it.